Okay, in this video, we are going to talk about dependent sample t-test. It's also called paired sample t-test, and it's also called matched sample t-test. So we're going to work on that one in this video. So let's open our studio. And again, go to top right and click open project. And let's get the folder path. And then paste that here, open it, and click this one, and open it. Okay. So since we already run the one sample t-test and independent sample t-test, that shouldn't take long. So let's open files, and this should be okay. It looks like last time I checked, I just looked at the data, so I'm going to go back one more, and this time we're going to open number 7, dependent sample t-test. So I'm going to close the first one. Okay, so in this one, basically the idea is, let's check the data file first. And it looks like in this file I'm calling one-pair job security SAV. So let's see whether that file is in the data folder. Okay. It looks like one-pair job security is not here. Oh, okay. This file is called 7. So I'm going to change that one to 7. So it's always a good idea to check whether the data file that you are reading in it has the correct name in your syntax. So especially if you are reusing some of these syntax that I give you. Okay. So basically, DEC tools is again for descriptive. Haven helps us to read SPSS files. So the first 12 line is basically reading in the data to R. And let's open our environment. That will help us to make sure that we were able to read in the data. Click run. Okay, my data is, we have 30 observations and 2 variables, and I have 2 variable pay and security. Okay, let's close that one. Let's save this one. And okay. So again, let's check the variable names. It's called pay and security, and let's put the descriptors for those two. Let's minimize this, and so for the first variable, the mean is 5.67, and for the second variable, the mean is 4.5. Looks like there's some difference, but let's check whether that's statistically significant. Okay. In line 21 to 26, I'm basically providing some background information. Like, for example, Woody's collected this data, and if workers are more concerned with job security or pay. 30 individuals who work in different settings, and ask each employee to rate his or her concern about salary level. So from this design, basically, what you're seeing is Woody is asking the same 2 questions to every single individual, and she wants to compare whether there's a difference between like their concern level in terms of job security or job pay. And again, since the data comes from the same individual for 2 different questions, this is a good example for a matched sample, paired sample, or dependent sample t-test. Okay. So I'm saying like dependent sample t-test, but don't confuse that one with dependent variable. Dependent here basically means that the same person is answering the different questions or same questions over time. Okay. So I'm just gonna run the non-directional hypothesis. Basically, in non-directional hypothesis, what I'm saying is there's no difference in terms of participants' concern about job pay or job security. Okay, and to do this one, what I'm basically doing is I'm telling R that I'm going to t-test, and my first variable is, I call it x, when it has to be called x. So it's equal to my data. Okay, my data set is called my data, and then I have a variable called pay from that data set. Okay, my second variable will call it y, and my data, so my variable security, and it comes from my data, so my data $sign security calls that. Mu is, we are checking for the mean difference, and the mean difference is going to be here like 0. So basically, the mean for job security and pay is 0. I'm testing against 0, so that's my null hypothesis. And for my alternative hypothesis, I'm saying that the mean is going to be different than 0. And here, when I say paired, so basically what I'm saying here is these two scores comes from the same individual. And I want to compare those two, and confidence interval is 0.95. Okay, let's run this one. But before we run it, let's clear up the console and to see the results. Okay, so, and again, after we run the analysis, R is telling us that we run a paired t-test or paired sample t-test, and the t-statistic is 2.82, degrees of freedom is 29, and the p-value is like 0.008. So basically this value is less than 0.05, and in this case, what it means is we reject the null hypothesis that there's no difference between people's concerns about pay and security. Since the first variable was pay and the second variable was security, and the mean of the differences basically tells you mean pay minus mean security is 1.167. So people have more concern about pay compared to job security. And if we rerun the descriptives, I'm gonna minimize this, and people concerned about job security is 4.5, and people concerned about pay is 5.67. And again, if you take the difference, you'll get to this number. Okay, and so what happens if we change the order of these two variables? Oops. So if I put security first, I'll try to redo this. I'm gonna copy this one, paste it here. Because it's the same data set, I'm just changing the order of the variables. And if I run this one, but for that, let's clear this again. But let's run both of them so we can see those. Okay. So if you notice, if we run the pay first, the t value is like 2.82. But if we run the other way around, it's negative 2.82. So, but in terms of the final decision about whether this is significant or not, the p-value is the same, degrees of freedom is the same, so confidence interval is same, but the change is sign, and this time the mean difference is negative. So we basically reach the same conclusion. So it doesn't matter whether you put the one variable first versus the other variable first. And in this example, I provided a sample APA style write-up, so you can use this one if you want. Okay, that's all for this video. Let me save this. And